Today we are going to talk about how the servo code for task 1 works. Integer servo pin is declared as a variable which is equal to which has a value of 9. Integer degree is declared as a variable. Integer timing is declared as a variable with a value of 10,000 milliseconds. Then we go to the void setup. Void setup has pin mode servo pin which is set to output on the Arduino. Servo pin is equal to 9, so the 9th pin on the Arduino is set as the output. Then we go on to the void loop. Void loop uses the for loop first from starting from 0 to 180 with an increment of +1. In the for loop, in the first for loop, there's servo underscore h degree. This can be found in void servo underscore h integer a. In this void servo underscore h loop, integer b is set as map, which is a scaling function where 0 to 180 is scaled to 544 to 2400. Then digital write servo pin high, delay microseconds integer, which is integer to b, which is the scaling function that I talked about just now, and it goes to digital write servo pin low, and then he delays a microseconds again, which is to 20,000 minus b. This is to simulate a PWM wave for the servo. Then after that we return to the earlier loop, which is the first for loop. Then we delay timing, which is 10,000 second for a rotation of 180 which is a delay of 10,000 milliseconds over 180 movement. Then after this loop ends, it goes to the second for loop. The second for loop moves from the 180 position to the 0 position, to the 0 degree position in a decrement of 1. The servo underscore h is the same function as I said just now, and this delay timing is the same duration as it turns from 0 to 180. Now it turns from 180 to 0. And that's all for the code.